So, for this project, you are going to design a roller coaster. And I have on here the tallest roller coaster, some tall roller coasters, and one that goes underground. Okay, so you can kind of see realistically the limits that you kind of need to stay between. Okay, you don't want your roller coaster to go up 1,000 feet in the air. That would not be realistic. Okay, we have to keep these somewhat realistic for the purchase. Okay, now I do understand that we're going to be a little bit limited in the physics category of a realistic roller coaster. Those of you who have talked about roller coasters in physics, we might not always obey the law of physics, but that's going to be okay. All right, there's only so much we can do with polynomials. Okay, so these are your requirements. Read them with me on your paper. Your roller coaster must be modeled by a polynomial of at least degree 6. Okay, that is at least. It can be more. You must have at least 5 unique zeros. Hold on. 5 unique zeros, but degree 6. Better have some multiplicity in there. Okay? You must include at least 1 zero with even multiplicity. Your roller coaster can start at any height. All right? The x-axis is going to be ground level. And the x-axis represents time. Where does time begin? 0. So if we're talking about an x and y axis, wherever your y-intercept is, that's going to be your beginning height of your roller coaster. You can start at ground level, you can start above, you can start below. But if you need to make a note to yourself, your y-intercept is where you're beginning. Okay? Your roller coaster can start at any height. Your roller coaster must dive below ground into a tunnel at least once. Shouldn't be hard to do. Okay? And then, like I said, the x-axis represents time, which means your y-intercept is going to be where you begin. Okay? So, essentially, I'm going to have you either work with Desmos. We haven't worked with Desmos in here yet, have we? Okay, so I'm going to show you what Desmos looks like. You can use your graphing calculator to do this, but as you can see, we're building a roller coaster, and so we could get really high curves, and that might be a little bit difficult on your graphing calculator, but you're still welcome to use it. Okay? The first thing that you're going to do, and I might actually not do this very first, but something that you'll want to do is you'll want to define your x and y units. Okay, you can see here that I picked zeros of 0, 1, 3, 5, and 7. Okay, my roller coaster is not going to last 7 seconds, and my roller coaster is not going to last 7 minutes. Right? Yeah. So what I decided to do, I decided to make every x worth 10 seconds long. So my roller coaster is really lasting 70 seconds, which seems more realistic, right? Okay. So that's why I defined my x to be that way. All right. Now, once I have my zeros, we have to write our polynomial, okay? What you're going to want to do is you're really going to want to play around with things until you get the roller coaster that you want, okay? So you're going to do a lot of work in Desmos before you write number 3. But once you have number 3, the rest will come fairly quickly, okay? So let's go to Desmos real quick. Is it popping up? Okay, so Desmos.com looks like this. what you can do is you can say, all right, well, here we go. Y equals, I want a 0 of 0, I want a 0 of 2, I want a 0 of 5, I want a 0 of 7, and I'm going to square it. Okay, you can see that, I wonder if this will work. The more zeros you add, this is a lot better with your phone. The more zeros you add, the higher and higher it's going to go. Do you see that? Okay. So one thing that I'll let you know, the bigger your zeros are, the more stretched out it's going to be, which is why I stuck with zeros between 0 and 10, so that I didn't get these crazy heights. However, we can do something about crazy heights because we can put a coefficient out in front, okay? A coefficient that is less than 1 is going to be a vertical shrink. So I put a vertical shrink at the beginning of my polynomial so where the heights of my terms were smaller. Okay. So in this part right here, you're going to have to play around in Desmos until you get a picture that you like. When you're doing Desmos like on a mobile device, you can really like zoom in and out with your fingers. Like here I was zooming out as a square. I really wanted to zoom out just on the y-axis, and on a mobile device you'd be able to do that. Okay. Once you get a polynomial that you really like, you are going to have to multiply it out. Okay? Now, some of you are freaking out about this. Don't. Have some patience, and you should know if you turn in a polynomial that is multiplied out correctly or not. Mrs. Holman, how would you know? What should be true about this graph and this graph? Then graph them together and make sure they're the same thing. If they're not, you didn't multiply them correctly. Okay? Okay? It's a lot of typing, you say. In Desmos, you can type in multiple equations. And do you see this red right here? If you don't want it to show, you click on it and it goes away. So you can have a bunch of things typed in your Desmos to where you don't have to retype it every time. You can just go back and fix. Okay? Next in your project, I am going to ask you for the beginning and ending behavior. If this weren't a roller coaster, what would happen? Okay, leading coefficient test here, people. Also, do you see how it says, give a reason for this behavior? Essentially, I want you to describe the leading coefficient test based on your polynomial. Okay. Most importantly, I want you to actually graph this roller coaster. Okay. Let's see if I can get to mine. Here is the graph of my roller coaster. Okay. Pretty sweet roller coaster, right? Okay. I go underground and I bounce off the x-axis. I'm meeting the requirements. Okay. Notice how I've labeled my x-axis as time, and I say 1 unit equals 10 seconds. Do you have to make that your unit conversion? No, but you need to label if you have one. Okay. I've labeled that my y-axis is height in feet. Okay. I draw my curves nice and smooth. And then I'm going to ask that you label your very minimum point and your very maximum point. How am I going to know those? Go to your graph. Here on Desmos, you can click on those turns, those relative minimums and maximums, and it will give you the coordinate. Draw it on your paper. Okay? Back to our graph. I have the name of my polynomial. Now this is pretty basic. If you want to color it, draw a little roller coaster car going down it with people screaming. Draw things in the background. Go for it. Okay? But I at least bare minimum need this right here. Okay? Based off of the ride of your roller coaster, I then want you to identify can I get to there it is. I want you to identify the roller coaster's domain and range. So my roller coaster lasted from x equals 0 to x equals 7, so that was my domain. My range, I looked at my minimum point and my maximum point, and that was my range. Okay. Questions so far? Okay. I will tell you that when you get to this part right here, like these three all go together. Okay? Figuring out your zeros and factors with a leading coefficient, and then determining what your units are, those are going to be all tied together as you're just playing around in Desmos until you find something that is realistic. Okay, you want something that is realistic. This is going to be due on Monday, so you may begin it now, you may begin it tonight, you may begin it tomorrow, you may begin it this weekend, but I would not suggest that. I would not suggest that. I have graph paper. I will probably need to track down some more. But I have graph paper for you in here for when you sit down to make your polynomial roller coaster. Okay? So I'll just leave that up here. Come grab one either today or tomorrow. I will also hand out the review so that if you want to start that before tomorrow, you can. But tomorrow's class time will be dedicated to the review. And if you have small questions about your roller coaster project, you can do those one-on-one. But I'm probably going to ask you to work on the review for a majority of the time. You might have a little bit of time if we need to switch back and forth. Okay. Questions before I let you go?